Hello and welcome. Today we are going to look at different effects of changing units. Changing units are very common in our real life. It could be changing from meters to kilometers, from kilograms to pounds, and so much more. According to our experience, we already know that such changes can affect the characteristics of the data, namely measures of center and spread, or more specifically, the mean, median, range, and standard deviation. I suggest those of you who don't know these concepts watch the video titled Measures in Distribution in this playlist to familiarize yourself with them before we get into this video. In this video, we will focus on the effects of addition and multiplication. Starting with addition, we will use the data presented in this dot plot as an example. This set of data is collected from a lab that measures the melting point of some kind of solid. On the left side, we have a list of the measurements in Celsius, but the scientists need to convert it to Kelvin scale, which for your information is equal to the degrees in Celsius plus 273. Now let's look at each data and plot them onto the graph in Kelvin. This dot represents a data of 28 degrees Celsius, and 28 plus 273 equals 301 Kelvin. So let's draw it here. These three are at 29 degrees Celsius, so that is 302 kelvins here. Similarly, we will transfer all the dots one by one to construct this graph on the right. Again, we will calculate the mean and the median, range, and standard deviation. What we will find is that the mean and the median are exactly the original value plus the constant 273, while the range and the standard deviation stay the same. And this makes sense, because we are essentially translating this whole graph on the left 273 units to the right. So the mean and the median shift the same constant value. However, the shape of the graph stayed the same. So, the measurements for the spread are unmoved. Next, we look at multiplication. This is a set of data from a museum to measure the length of some pieces of antiques they found. They had their measurements in centimeters on the left, but we need to change the unit into millimeters, which, mind you, is 0.1 of a centimeter. 0 centimeter is 0 millimeter, so let's draw this dot here. 1 centimeter equals 10 millimeters, so they're here. Likewise, we transfer the dots representing 2 centimeters, 3 centimeters, 4 centimeters, and 6 centimeters to the right graph. Then, when we list out the measurements, we discover that the mean is 22.5 millimeters. This value is 10 times the original 2.25. Same goes for the rest of the measurements too. All resulting values are the original values multiplied by the constant 10. This is because we are essentially stretching the left graph horizontally to get to the right one. Meanwhile, the z-score, by definition, the measure of how many standard deviations from the mean a value is, do not change under both situations. In addition, both the value and the mean shift by the same constant value, and the standard deviation doesn't change, so the z-score in both units are the same. For the multiplication part, all of the value, the mean, and the standard deviation are multiplied by the same constant value, so the z-score doesn't change either. Recapping. In this video, we talked about the effects of changing units. We discussed what change addition and multiplication would bring to the mean, the median, the range, and the standard deviation. We also explained why the z-score never changes after the operations. I hope you enjoyed this video and see you soon.